Hello everyone and welcome to my video about network address translation. So the purpose of this video is for you to understand how NAT works together with IPv4 and also to get to know about other protocols often used in the internet. So that will be a last finalizing slide. So about network address translation. The primary goal of NAT was to create a fast, smart and temporary solution to the problem that there were too few IP addresses. We already saw in a previous video that we had this problem with assignment of IP addresses, and it is a general problem that the world is running out of IPv4 addresses. So the idea is that instead of every host on the internet to have its own address, it's enough that people can share addresses within a network or within an internal network. And then the gateway to the outside world will have an external IP address and take care of forwarding of all the packets. For packets coming from the inside to outside, this is actually quite easy because you just have to adjust the source address. But some consideration is needed in order to send packets from outside to the correct internal host. And all this mechanism is what we'll be looking at in this video. So for incoming traffic, it is necessary to know where on the internal network the packet should go. So if a connection is established from a machine on the internal network, this is done by looking into and manipulating the TCP and UDP headers. If other protocols than the usual TCP and UDP are used, then we must handle these often explicitly. Certain applications can create troubles, especially if you attempt to run servers behind a NAT box, and some of you might also know this. On the other hand, this is kind of also why you could say that you can consider it to be more secure to run your local network behind a NAT box, because you don't have your host exposed directly to the internet. So when using network address translation, first of all, we have three ranges of IP addresses that are used in internal networks. And this corresponds also to the classes we have seen before. So one is 10, starting in the range of 10, one is starting in the range of 172, and one starting in the range of 192. So if you have one of these addresses, it's probably an internal address. Today, NAT boxes are usually combined with a firewall. With an increasing fear of virus attacks, etc., NAT gives actually by itself a certain protection because it hides the user's IP addresses to the outside world. And also an extended NAT box, so to speak, it gives companies good possibilities to filter traffic and avoid abusing connections, to avoid abusing the internet capacity or the working time of employees, because you can limit what is coming in and what is coming out. So often you will see the NAT box in combination with this kind of functionality. So in a typical NAT setup, the host computer, so on the internal LAN, has a range of IP addresses. So that could be 10.0.0.1, 10.0.0.2, 10.0.0.3, etc. The NAT box is then usually the gateway to the outside world, and it will have two IP addresses. It will have a local IP address, and it will have a global or external IP address. So in the case here, we see that our local IP address could be 10.0.0.1, and our outside global IP could be 190.54.68.45. So when it comes to the internal addresses, these are handled and assigned locally, for example by the gateway, who will usually be running a DHCP server. So when you connect a new device on your LAN, you need either to manually or have automatically assigned an internal IP address to it. And the external addresses is usually provided from that person's internet service provider. So the NAT is kind of what is in between the company area network, the internals and the outsides of that. So how do we send and receive packets in this setup? So assume, and there is an example below, where we are sending a request from one IP address 192.168.1.17, so that's an internal IP address. And we are sending a request to an external server, where we also have the address 194.71.107.15. To understand what is going on, we need a little TCP because we're actually manipulating the TCP header here. So in TCP we are using port numbers for addressing. So we assume that it is sent from port 58296 at the internal host to port number 80 at the external server. So all we need to know about TCP now is really that we are using these port numbers and that TCP has port numbers in the header. So when we send it from the internal host, it has this IP address which is listed down to the left and this port number. Then we have the gateway NAT, which has an internal IP and an external IP, and we have the external server that we are communicating with, which has also an IP address and the port number. So what we want to do is we want to send a packet from the internal host to the external server, and we want to have a reply back from the external server back to the IP, back to our original part. So when our packet will leave our internal host, it will have a source IP, which is 192.168.117, and it will have the source port, which is 58.296. Then for the destination address, it will have the IP address of the server that we are sending it to, so the external IP address, and will also have the external destination port. So the host doesn't do anything special. It just sticks to its own IP address and sends the packet to the external server just as it would do if it was on the network, outside network itself. In step 2, what is happening is that the packet passes through the netbox. And when the packet is passing through the netbox, then we have to change the source IP, because this internal address doesn't make any sense when we go out on the external network. So the source IP is changed to be that of the gateway. So we know that when we get the packet back in return, it will be sent to our gateway. Then the problem is that we need the NATbox, our gateway, need to know what to do when the packet response is returned, because there might be many internal hosts behind the NAT, and it has to be able to send it to the right one. So what we do is that we assign this connection an ID that could be, say, 10,000, and then the NATbox keeps track of this connection ID, and to do so, it puts it in the source port field. So when the packet is leaving now the source, the gateway, it has the source IP 198.60.42.10, which is the external IP of the gateway, and it has the source port 10,000. Because when the packet is returned to the gateway, then because the source port is 10,000, the NAT or the gateway will look up 10,000 in the table and know which internal host to send it to. So then the packet is sent to the external server, now with this source IP and source port that it just got, and the destination IP and destination port that was not changed in the gateway. When we make the response here, then the external server doesn't know anything about the packet coming from a host behind a LAN. So it will put the source IP and the source port of the external server, and it will put the destination port and the destination IP to that that was the source port and source IP from before. So now we will send it back to the gateway, and we will send it with 10,000 as the destination port. So as just prescribed, when we then arrive to the gateway, we will look into the table and see that 10,000, that corresponds to this particular IP address and this particular port number. So we both know the destination IP and the destination port because it was saved in the table. The port was the original port, the original source port, and therefore we can send it to the right place. So neither the internal host nor the external server need to see any of these translations. It's only handled by the NATbox. So this is the case when the connection is initiated from the inside. Of course, if you initiate the connection from the outside, for example, if you're running an FTP server in your internal network, then you need to tell your NATbox explicitly how to handle this. Also, there are some other criticisms of NAT. For example, that NAT breaks the fundamental IP design of one rule, one machine, one address. It transforms IP to be connection oriented because you actually in the NAT box have a connection. It breaks the principle of layer protocols because even though we are communicating this in layer 3, we're still manipulating the content of layer 4 because we're using the port numbers of TCP or UDP. So this makes it very hard to make a new transport protocol because then it would not fit into the NAT. And then there is also a limited use. One is that there is a limited maximum of 61,000 connections, or 61,404 connections at the same time, which is due to the limitation of the TCP header and the size in the TCP header that we can use. But you will also often experience that if you have a cheap NAT box, there is further limitations because it cannot handle so many simultaneous connections. Just to mention a few other network layer protocols, is that we have the Internet Control Message Protocol. You might know it if you have been trying to ping IP addresses to measure the time it takes to send a packet back and forth between two machines. We have IPsec, which is secure IP. There is mobile IP, and there is IPv6. But these are not really covered in this course, but you are free to study them if you're interested. So this is the end of this video. Thank you for listening, and please let me know if you have any questions or comments.